Last session for today is with Simon MacDonald. Simon has over 20 years of development experience and has worked on a variety of projects, including object-oriented databases, police communication systems, speech recognition, and unified messaging. And he's going to be talking today about some of his experiences building web applications since, sounds like you actually have dark old day memories just like I do. Thankfully, I wasn't writing shell scripts as much, but I do remember there was no table tag in the first website that I worked on, just to set a little bit of context there. Simon, I really can't wait to hear more about what you're going to be describing and things we're going to be covering here about the way things get rendered and the order in which things happen, and how you can maximize that. I'm going to stop talking now and let you take it away. Thanks for joining us today.
Oh, thank you so much for having me here. And I just want to, again, thank the organizers of Web Unleashed for having me speak at this event. And to reiterate what you just mentioned, if you didn't see some of the talks from earlier today, I really have to recommend Adi Osmani's talk from this morning, The State of JavaScript in 2022. You definitely have to check that out and watch that replay. I love that talk. And yes, I am super old. Maybe you didn't have the table tag, but you should try building a website when you don't have the image tag. That was the bad old days. CGI had been using C in order to provide interactivity. But anyway, let me introduce myself really quickly. I'm Simon MacDonald, and I'm the head of developer experience at Begin. So that's me and Regina from earlier this year, where I was giving a talk. And this is my slide of Infinite Simons, where each one is a picture of me from a previous talk. And it goes back about 40 some talks. And someday I'm just going to give a talk where it's nothing but me pointing to myself all the time. Anyway, if you need to get a hold of me after the event, please just hit me up at Twitter, where my username is @MacDonaldST. Again, it's a stupid username, but it was always available, and it was my Unix user ID from way back in the day. All right. So I just want to preface this talk with the fact that I love JavaScript. I mean, I really love JavaScript. I don't want anybody to get the impression that I'm anti-JavaScript. I write JavaScript every day, and I mean, we all love JavaScript, don't we? Some of us love it a bit too much, though, and that's just like what Adi mentioned earlier today. One of the most expensive things with your web application is how much time it takes to parse, interpret, and execute your JavaScript. And our over-reliance on it is causing some of our web applications to run a lot slower than they need to. But we'll get to that later. So why do we care about the main thread? And that's because a lot of stuff happens on the main thread. Now let's dig into what the main thread of the browser actually does. So let's take a look at some of its responsibilities. First and foremost, it parses all the HTML. So when the browser makes a network request and the HTML comes down, it parses the HTML in a very forgiving browser that even badly written HTML still displays properly, which is amazing. And then it takes that HTML and builds up the DOM in order for you to be able to manipulate it. It then parses the CSS that is downloaded, applies that CSS onto the page so that you can style up all those fun HTML elements. And then it'll download, interpret, and execute the JavaScript so that we can provide more interactivity in our web applications. And finally, it responds to any kind of user events that are happening. So the problem with this is any kind of long-running JavaScript process can effectively block other important tasks like responding to user events or repainting our UI. So just like Adi mentioned earlier today, this JS execution is the most expensive part of all of these tasks that could be happening on the main thread of your browser. So let's take a look at two important numbers. The first is 60 frames per second. That's the rate in which animations in our web browser will appear to be smooth. And if you want to get a rate of 60 frames per second, that means that the browser has approximately 16.7 or 16.666 all the way to infinity milliseconds in order to execute scripts, to recalculate styles and do any layout updates if required, and then repaint the updated area. Again, any kind of slow JavaScript or expensive CSS can block this from happening efficiently, and that's going to cause some jank in your web interface because the browser is struggling to hit this kind of smooth refresh rate. So I want to go to what the state of the art is in new frameworks. Actually, sorry, this doesn't have anything at all to do with JavaScript, but I just literally had to make fun of Meta for being excited about legs. Is legs really the killer feature? Is that's what keeping us from the metaverse? I don't know. Anyway, I just had to get that in there. So this time let's actually look at our state of the art HTML or in JavaScript frameworks that we're using. So a typical index.html for most modern JavaScript frameworks looks a lot like this. We have this div, which is our insertion point for the framework that we're using to be able to insert any of the generated HTML that it comes up with. And then, of course, we have our script tag, which is going to load the JavaScript for our application. Now, if you're splitting up your JavaScript into a bunch of different files, and you should in order to make sure that you don't parse too much JavaScript on the initial load, you'll be able to load additional JavaScript files later on. So let's ask ourselves the question, what if JavaScript fails? Yeah, that doesn't happen there, does it? Well, it's okay because the modern frameworks that do client-side rendering using JavaScript, they have a way to take care of that. They have a no script tag, which is laugh out loud. Good, you're out of luck. There's not much you can do. So if you're doing client-side rendering and you're completely dependent upon JavaScript, lots of users are having issues with your JavaScript. Will just be stuck at this point in time. But you're probably thinking that JavaScript never fails. It just doesn't happen. I mean, probably not for you because you probably have a pretty up-to-date machine and a really nice network connection, but that's not the case for absolutely everybody. When we take a look at various studies over the past 10 years or so, we estimate that the JavaScript failure rate is somewhere between 1% and 2%. Now, for some people, that probably seems like a really high number, when for others, it may seem like a really low number. But since about 2010, 2011, this is pretty much the number that numerous studies have come up with. So let's take a look at some reasons why JavaScript may fail. Well, first and foremost, there could be a network error trying to load that JavaScript file that the user has requested as part of the framework that's going to build up your entire application. So that's pretty common. Network requests do fail. Some corporate firewalls will end up blocking CDNs. And if the CDN that you're using to host some sort of important third-party JavaScript that you depend upon, then your entire application could be broken at that point in time. Well, there could be something interfering with your JavaScript. There was an issue a number of years ago with an ISP kind of messing with the DNS, and that was causing all sorts of problems with our web applications. But also, if you've ever gone to an airport and got on airport Wi-Fi, you can see how those vendors kind of mess with things as well. And your application, if it's not set up properly, may fail under those situations. Now, the thing everybody seems to immediately jump to when you talk about a zero JavaScript solution is that somebody has gone into their browser and switched JavaScript off. That's not as common as you may think, but also it's not a really good reason in order to build your application for someone who's not using JavaScript. I mean, they're making a choice at that point in time, but with an HTML first technologies, you can provide an interface that works for them. So that's what people usually jump to, the reason like, oh, people never switch JavaScript off. But you can see there's lots of other reasons why JavaScript may fail. Now, do they have a data saver mode turned on? So in Chrome, if you're in a low latency network, like a 2G network, for instance, if data saver is turned on, it doesn't even try to download anything in the script tags. So in those situations, if you're relying completely on JavaScript, things are just not going to work at all. And if you're here in North America, you think, oh, well, I never have to do that because I'm always on 5G. But do you have a teenager? Because I know that mine turns on data saver all the time because she's on a pay-as-you-go plan and she wants to save every last kilobyte of data so that she doesn't have to pay more for it. So these things do happen. And as well, is there some kind of browser plugin that is messing with your JavaScript? Or is it messing with the DOM so that it doesn't show up in exactly the way that you had intended, and therefore things are just failing kind of randomly? And then, of course, this is one of my personal favorite: is there an ad blocker installed? Ad blockers do tend to mess up your sites. So I'm Canadian. I live here in Ottawa, Ontario. I do order from Canadian Tire occasionally in order to get, salt in order to keep my driveway clean. And when I try to go through Canadian Tire, I need to have a completely separate browser profile that has the ad blocker turned off. Because what I've found is when the ad blocker is on, the JavaScript that is part of the shopping cart experience on Canadian Tire just completely fails. So I actually have a link on my desktop to take me straight to Canadian Tire. And then, of course, there's older browsers. I mean, we can get around that often by transpiling our code so that we can target older browsers. But sometimes your target may be excluding an older browser completely. There was an example in the not too distant past where a lady was trying to book her COVID vaccine, and she couldn't because it didn't support the more modern version of JavaScript that was required on the booking site. Now, do we really need JavaScript in a booking site? In a lot of cases, it should just work as an HTML form without JavaScript being required. So all of these reasons and many more are reasons why we have that 1% to 2% failure rate when it comes to JavaScript on our web applications. Now, as your site becomes more and more popular, this relatively rare occurrence becomes something that happens more and more regular. And that leads us to interfaces that sometimes look like this. So many spinners. They just go around and around. Sorry, I get distracted sometimes. And if this should really worry you, and if you're not worried, please take it from the talk that you should be. Now, all of these errors where JavaScript is failing to load, they're costing you money, either directly in lost sales, in the case of the Canadian Tire example that I used, or indirectly because your site is being ranked lower on SEO scores and it's not showing up as early as it should. So we have to think about how we can build our sites without JavaScript in order to be able to get around these kind of situations. Which takes us to our first adventure and rendering off the main thread. So the best way that I know to avoid JavaScript failures, reduce JavaScript bundle size, and to stay within our performance budget is to skip client-side rendering altogether and make sure that our initial render is done on the server side instead. So that's just sending HTML directly down from our server. So let's just do a quick overview of what SSR is. The browser requests a page and our server responds with accessible HTML. So it's coming down over the HTTP request. The browser then renders that HTML into the viewport. And at this point, it's not just viewable, but if you build in an HTML first or progressive enhancement techniques, then it is interactive as well. So even if JavaScript fails to load later on, they're still able to view the data in order to complete tasks by using the venerable form tag and server-side processing in order to be able to complete a sale or book a COVID test. Then, oops, wrong direction. Then the browser requests a JavaScript file from the server, which makes a lot of sense. And then, of course, the JavaScript is parsed by our browser. Listeners are attached to various elements on our page as it's progressively enhanced in order to be more interactive. And that's great. We're not saying that you shouldn't use JavaScript in this situation. We're just saying that, hey, you should probably make sure that it works in straight HTML first, and then make things better with JavaScript after the fact. So some of the benefits of server-side rendering, we find that the time to first interaction is super fast because we are sending down HTML that works in all situations. There is no reason why people could not start using the application immediately. As well, you get better SEO. Search engines can crawl and index your site way easier than they can with client-side rendering techniques. And it really doesn't matter how old the device is. Like all devices, no matter how old they are, can display HTML. That's a given. And it doesn't matter if you're not beholden to JavaScript at that point in time. It doesn't matter if the device is running a really slow processor. It's not going to have the penalty of this thing not working. And it also doesn't matter if the network is slow because the initial load that shows up onto your browser is already usable. It's a pretty good benefit. Now, some folks may ask the question like, well, wait a minute, isn't server-side rendering slow? And the answer to that is no. It really isn't that much slower. While the time to first byte may be slower than a client-side rendered solution, we find that the time to first interactivity will be way better with a server-side rendered solution. So, any kind of modern functional web apps which use cloud functions in order to deliver HTML to the browser and is backed by modern cloud based databases. And these databases are wonderful because they offer single digit millisecond latency when it comes to retrieving your data. And these kind of solutions are more than fast enough to compete with the most modern of client side rendered applications. Um, if you want to read more about something like this, I would suggest you visit fwa.dev. It does a really good job of describing that kind of architectural platform. So, the first lesson in rendering off the main thread is to leverage the server to do the initial render. This way, you're not sending down JavaScript in order to do the render. You're taking care of it from the server. You're not even overburdening your main thread at this point in time. All right, on to adventure number 2. Well, we'll take a look at building our application using reusable components. Well, we may ask ourselves the question, can I still use a component framework when I'm using server-side rendering? That's a really good question. And the answer to that, of course, is yes. Yeah, you can. There's many modern frameworks like Next or Nux that provide the ability to use components with React and Vue. Those are wonderful solutions. And if you're using them today, bravo, good for you. But I have to ask a question to respond to that initial question of whether or not we can use frameworks. Why would we use a framework when web components already exist in all modern browsers? So, what are web components? Well, they're a set of different specifications that are all grouped together to provide reusable component functionality in the browser. First off, we have the custom element specification that gives us a way of defining reusable components that can be added to the browser. Um, we have the shadow DOM, which allows us to encapsulate styles. That allows you to style your component and not have those styles leak to other parts of the page and mess up the CSS with other parts of your page. And then, of course, we have slots and templates. The slots allow you to compose your web components out of other HTML elements or other web components as well. So you can compose components out of other components. And the templates allow you to instantiate more than one instance of your web component on the page. So this is great. All of this functionality is already native to the browser, so you don't need to immediately reach for a JavaScript framework in order to provide the equivalent functionality. So let's take a look at a pretty contrived example of a web component. Let's just take a look at a hello world. So the first thing that we end up doing is defining our custom element in this template. And our custom element is pretty simple. We just have an h1 tag, and then we're going to say hello, and then we're going to populate that slot. This is a name slot with whatever data that is passed in when we put the component on our web page. And then in the constructor for our hello world, which is extending from HTML element, we are attaching to the shadow DOM and appending the template that we had just created in the previous step to our DOM and our web page. And then finally, we'll call this JavaScript API custom elements in order to be able to define our hello world. So anytime the browser sees hello world as a tag, it's going to use this hello world class in order to instantiate things. An important note that sometimes people may miss when it comes to defining a web component, you need to have a dash somewhere in there. It can't be the first character of the name. And in fact, most times you will see 2 to 3 words separated by dashes in order for it to be a valid custom element name. You could actually have hello dash and then nothing after it, but that looks very weird and I don't recommend doing it. But if you decide to play around with web components and just call your web component hello, you'll run into a whole bunch of issues because the browser won't know what to do with it. Anyway, just a quick aside for you there. Now, what does this look like on a web page? So we're going to use our hello world tag just like any other HTML tag. And inside of it, we're going to pass in our span to be able to tell it who we want to say hello to. And this is a name slot. So you can see that the span has an attribute of slot and the value of that is name. So that will show anytime we have that name slot, we will replace this slot in our template with what we pass into the hello world web component. So getting back to this, since the web components are reusable, we can use more than one of them on a page, and we can pass in different slots or in different attributes in order to control their behavior. And in this very contrived example, you can see that we're saying hello to FITC and hello to all the folks in Web Unleashed. So that's a pretty easy way to be able to build up reusable components, and we didn't even need a framework for that. Well, you might be thinking, whoa, wait a second. You spent the first half of your talk telling us that an over-reliance on JavaScript was a bad idea. And now you're saying we should use web components, which definitely depend on JavaScript for our UI. Aren't you contradicting yourself in this situation? Yeah, I was kind of hoping you wouldn't notice that, but you're all pretty smart. So that's why I recommend using this open source project, which is called Enhance. And Enhance is an HTML first project. You can read the documentation at enhance.dev. And let's just dive into a little bit of what Enhance actually does for you. So since Enhance is an HTML first framework, it's going to leverage web standards. So you write web components just like you would for a normal client-side rendered solution. You can reuse web components that already exist. The main difference is that Enhance expands your custom elements on the server. So what that means is it will take a look at all of the data that you pass into it through slots and attributes. It will create the HTML for you. And the HTML that is sent down to the client already has this custom element expanded before any kind of JavaScript is run. So it does that first pass for you so that you already have working HTML that lands on your client. So it's immediately viewable and interactive. And then you just continue to enhance, see what we did there, your application with the JS that you need in order to provide more advanced functionality. And I got to tell you, in a lot of cases, we found that we can build an amazing HTML first interface and not need very much JavaScript at all in this kind of situation. But basically, if you are interested in this, check out enhance.dev and just know that any of the web standards that exist will be supporting them. Now, our second lesson in rendering off the main thread is just use what the browser already provides you. Of course, you can use a JavaScript framework to provide reusable components, but why would you? If the browser already provides a mechanism for you, not having to rely on a framework helps keep your JavaScript bundle size smaller, and it helps keep you within your performance budget goals. It's the same thing, like, I would love to see a show of hands, like how many people have built their own date component picker. And I'd say a lot of people are probably raising their hands right now, and it's a huge pain in the butt. And there's a lot of issues around accessibility and working, in a non-JavaScript environment as well. But I got to tell you, if you just type input type equals date, you get a really good accessible date picker. And so, the platform has gotten really good in the last 5 years, folks. So if you haven't investigated some of these things, you should really check them out. All right. So this is where my metaphor of reduce, reuse, recycle kind of breaks down a little bit. So we'll change that third thing to offload instead. You're probably thinking, wow, finally, this guy's going to talk about what we can do in our browser to move JavaScript off the main thread. And you're right, we finally gotten to that point of the presentation. Now, web workers are this wonderful browser feature that allows you to spin up a separate background thread to do computationally expensive tasks. They have a subset of the browser APIs available to them, Things like doing fetch for network requests. You can use the Web Crypto API. This is a really good thing to put into a web worker as well, because it's very expensive. And of course, IndexedDB. So you can always share that IndexedDB instance between your web worker and your main thread in order to pass large amounts of data. But of course, we'll talk a bit more about how we can pass data between the two threads in a moment. Plus, Windows functions like set timeout and set interval can be used in a web worker. So that's a really awesome way to be able to schedule jobs. One of the things, if you need to do some sort of background polling because you're integrating with an older backend system that doesn't have an event mechanism and you need to poll it, you can start up a web worker, do a set interval, and the web worker will make a network request every X number of seconds as you specify in order to be able to do that polling. So that's a pretty awesome way to be able to offload that from the main thread into a web worker. However, there is some downsides with the web worker. They don't have access to absolutely all of the browser's APIs. And most importantly, they can't manipulate the DOM directly. And you may think that's kind of funny, but it's not that uncommon. If you've ever done any iOS or Android programming, all of the UI stuff has to be done on the main thread. So much so that in both of those operating systems, the main thread is actually called the UI thread. And when it comes to communication between the main thread and a web worker, it's done via the post message method. Wow, say that 5 times fast. I can't, not without taking another drink, that is. So let's go through a little example here of using post message. So we have this fictional application. It's a to-do list thing, and the user has filled out a form with all of the information for our new to-do item, and they've clicked save. So that button is then executed, and we're going to call post message to send that data to the web worker. And in the web worker, once the post message is received, and the on message event is fired. So what is happening at that point in time is we're going to grab that data from post message. We're going to make a fetch call to our backend server in order to be able to store that new to-do in a database so it's not lost forever. Then once that backend server responds to us, the web worker will take that result and send it back to the main thread using post message again. So the post message works in both directions. And then so once this is updated on our main thread, it also responds to the on message event. And in this case, we're going to update the store in our application and have that store just emit an event so that any of the web components that are dependent upon that particular property in the store can go ahead and update themselves. Now, let's take a look at what this process is like in some code. So we have this API component or API file, and the user has clicked on a button to save a new to-do. So it calls the function save to-do. The first thing that we're going to do there is to check to see, has a worker already been created? If it hasn't, we're going to create our new web worker from worker.mjs. Your web worker code basically has to be in a separate file. That's just one of the things that you need to know when you're working with these things. And then once we create that new worker, anytime it's on message is called, anytime it calls on message, we want the mutate function in this API to be called so that we can respond to those changes. And then we're going to take the to-do that was passed into the save to-do method, and we're just going to say worker post message. So that's the point in the previous diagram where we're saying like, hey, we're going to send this to the web worker itself. That's what's happening at this point in time. So taking a look at our web worker, you can see that it refers to itself as self. I think that's a really smart thing, because imagine if we had one more place to think about this and what this means in JavaScript. So in this case, a web worker is called self. And anytime the anytime a message is posted to the web worker, this on message function is called. And what is going to happen at this point is we're going to communicate with our backend in order to save that to do. So it's going to do a fetch network request, posting the data that we received. to our backend database. Once that result is received, it's going to convert it into JSON. And then once that's all done, we are going to say self post message this result. And in this case, we're saying like, okay, we want to send this new data back to the main thread. Sounds good so far. Now, back over in our API component, we have this store. We'll get into that in the next bit. And what we want to be able to do is when the post message is called from the web worker to our main thread, this mutate function gets called. It's going to make a copy of all of the to-dos that are currently in the store. Then it's going to push our new to-do onto the store. And finally, it'll set the store.todos equal to this copy. Why are we going through the pain of doing a copy of this array? Well, mostly it's so that if there's different threads that are working on this, we keep it thread safe and we don't kind of blow everything up, because that will cause a nice JavaScript error for us. All right. In the store API, we have a way of subscribing new listeners, unsubscribing listeners, and then what is going to happen is we have this notify function. So anytime notify is called, we're going to loop through all of the components that are currently listening for changes and call the function that they've registered with our store, which is not too bad. And then we have this fun handler object here. So what we're doing is we're overriding set. So anytime the store has a new property set to it, or sorry, a property on the store is set, we're going to check to see if the value of that property has changed from what the previous value was. If the value of the property has changed, we're going to update it, and then we're going to call our notify function so that all of our listeners will know that a new to-do has been added to our store. And then we return true to say that we've properly handled things. So our store itself is a very simple proxy where we have our state with our subscribe, unsubscribe, and notify things, and our handler takes care of any time things are set. Now, over in, let's say, one of our components, I have our full to-do list. Again, it's just a standard web component that we write. In the constructor, we'll instantiate our API. So that is the piece that is going to handle the communication between the main thread and the web worker. And then we bind the update. It's kind of the same thing that you would do in a React application as well. Now, on the connected callback, we want to subscribe this web component's update method. Anytime the to-dos is changed in the store, we want to be notified of it. So that is what we're doing in the connected callback. So each time to-do list is instantiated, it will register this connected callback. And then, of course, when the to-do list is unloaded from the browser, we'll unsubscribe for this to get rid of that dangling reference. And our update functionality is pretty simple. All we're really doing there is we get this new list of to-dos from the store, and we're going to filter it out into which to-dos are active, which to-dos are completed. And at the end of this, the web component will handle making all of the changes to the UI so that it's been updated. So yeah. That is kind of the third lesson of rendering off the main thread. Anytime you get into any expensive operations, you'll want to kind of move them off into a web worker. But the thing is, you don't really want to start working on this kind of things until you've kind of mastered the first two lessons, which is basically server-side rendering and use what the platform gives you before you get into writing kind of this bespoke JavaScript in order to provide this functionality. All right. So in conclusion, and I'm sorry if I've rushed through these things, first thing that you should do is reduce. Just the best way to keep your bundle size small is to start with an HTML first mindset. So if you can get away from having to use JavaScript in order to build UIs and start with regular HTML in the browser, that's a great way of being able to hit your performance budgets. Reuse what the platform already gives you. Maybe don't automatically reach for a framework to solve your problems. Look into what the platform provides. There's been a ton of advancements in the last 5 years. The other nice thing about web components for building your applications is that they're actually pretty well supported so that you can use them in a React application or a Vue application. So you don't immediately need to, I'm not saying, hey, if you've got a wonderful built application, you don't need to throw away everything, but you can start the transition already into reducing your JavaScript size by using web components. So if you have to build a new component, maybe try web components and adding it to an existing application. And then, of course, offload. Anything that is expensive, get off of the main thread. Pretty much reserve your main thread for doing UI updates or responding to user events. So like anything that is network communication, that is a really good thing that you can move off to a web worker in order to make sure that you can respond to UI events really quickly. And I think every presentation should probably end with a pithy statement. So hat tip to Michael Pollan here. So use JavaScript, not a lot, and mostly for progressive enhancement. So if you want to get in touch with me, you can hit me up at MacDonald. I'd be happy to answer your questions either now or after the conference, and check out what we're doing around on enhance.dev. So thank you so much for your time.
That was awesome. Well, I'm just going to make an excuse now. The long guy is literally outside the sliding glass door immediately to my left, so I apologize for the background noise. But just consider that the gentle buzz of the fans in your laptop running when you're consuming everything on the main thread. So just try and tie that right back.
Well, so I have folks putting in fiber into the entire. I'm actually shocked. This is why this whole setup is done here today, because there's literally people drilling through driveways in my neighborhood right now.
Well, just to say it again, Simon, that was absolutely fascinating. I just love the way this connects pardon the pun, the threads throughout the day. In this main thread, my question for you is, what's the best way for us to try and understand with dev tools, if there is a way, what's going on what thread? What can we look for when we start to audit an application and say, understand where we should shift something to a different way of communicating? And I'm going to mute and let you answer.
Yeah, there's lots of good dev tools depending on what browser you're using in order to be able to profile your application. You'll be able to check out, what your main thread is doing. I'm not an expert on this in any way, but you actually should look into some of the other things that Adi Osmani has written on this, and he'll be able to specify like, oh, this is where layout is happening, this is where paint is happening, and this giant red block here is where JavaScript is happening, and it's preventing your user from being able to click on buttons and respond to events. And once you identify those bottlenecks, then you can start to break them up into smaller pieces. You can move some of that off to a web worker. You can look at using request animation frame or yielding the execution of your JavaScript in order to prevent that from happening.
That's awesome. Thank you. There were a couple of other questions in here. Now, I know that don't use the framework is a good first step, but for many of us, that's not really an option. So to any of them like React or anything else, have a good practice or a way to delegate those expensive operations off the main thread. Is there anything built in any of them that you know?
So when you're using a framework like React or Vue, and I don't want to pick on any one particular framework, I think they're all wonderful. They provided amazing developer experience. Yeah, I mean, I probably could, but they kind of lock you into a certain way of doing things. So bringing stuff and having it fired off into another web worker is a lot harder to do in some of those various frameworks. I don't really know how to answer that properly right now, but I do know that it is a little bit difficult. What I would suggest to folks if they're, having performance issues with some of these other frameworks is, again, to profile their application, see what the bottleneck is. It usually ends up being a situation where you've changed something and it's actually done the layout 4 different times, which can cause all sorts of problems. So some of the issues that you'll run into in these different frameworks are a little bit different than you would run into if you had just like bespoke solution. Um, but if you really want to start reducing your bundle size, as I said, you can start building web components and taking advantage of what the browser already gives you instead of having to build everything as a React or a Vue component. And over time, you can migrate your application to the browser standards instead of sticking with a framework. I mean, I always bet on the web. I think the web and the platform is always going to win out eventually. One of the things that we decided to get off this kind of hedonistic treadmill of all of these frameworks updating and breaking our applications every 6 months to a year is we wanted to really get back to web standards. And I'm sure there was probably some update of a framework today which promises all the bells and whistles as soon as you rewrite your application to do it the new way, which is a lot of unplanned work that you just don't have time for.
Yeah, I think that goes straight back to our last conversation about whether or not anybody ever updates the front end or the back end of their website without ending up throwing everything else out anyway. So going back a few years, I was on a panel actually at an earlier Web Unleashed about web components. And one of the things that I found really frustrating was that there was no way within a web component to really be referencing your global styles. And with that, then it just meant that you had to, pack your styles into every single web component as well, which just seemed like it seemed like a lot of waste. What's the state of that now? Is that different now, or is it still the case?
Yeah, I'm not aware of that being a problem before, but I completely trust you. I know that since I started using web components, I'm able to take basically our enhanced styles package, which gives you a bunch of utility classes you could use, or Tailwind, and those are loaded in the head as global styles. And then I'm just able to use them inside of my web components when I'm styling it. So that is working just fine for me. As well, one of the things that Enhance does when it's going through and converting your custom element, it's doing the expansion on the server side, is it's going to take any of those styles that are in there and put them into a concatenated style tag in the head of your document. So that, but again, still scoped to your particular components.
Got it. Well, I will admit that my knowledge of it is probably from pretty early on in the process, so it may very well have been something that shook out in the standards process. But we did have another question. We've got time for maybe one more from Sergey asking about what about service workers, edge workers? Are some of these other technologies things that are worth exploring as well?
Yeah, certainly. And a service worker is a specialized version of a web worker. So there is an API that it is able to allow you to work with. I would seriously recommend not to write a service worker by yourself. It's a really good way to shoot yourself in the foot with a bazooka. Then you have all sorts of trouble getting rid of that service worker. Was it service worker toolbox? Anyway, they may have changed the name of that, but it was a really good package that enabled you some common functionality that you would end up doing. For instance, with a service worker, one of the wonderful things that you're able to do is it intercepts all of the network requests that are going from the browser to the network. So that allows you to cache things like images. And so The only problem with that is if you don't write that logic properly, you may end up serving that image for the rest of time. So the only way to get around that is to change the name of the image. And that's really not what you want to do. So using something like the toolbox in order to make your service worker a lot easier to deal with is a recommendation from me.
Yeah, I feel like if anybody were sketchnoting this conference, they'd be having a field day right now. That was, I think, I feel like we could ask a lot more. But there was actually, there's one that came in before we wrap up from Derek, a little bit more of a general question about how designers feel, or in your experience, that JSX syntax mixing HTML with JavaScript. I know it gives me agita a little bit having to deal with that whole syntax, but I'm curious what your experience has been with the sort of general acceptance of that mixing of concerns, as it were.
Yeah, I've actually seen a really good adoption lately with using web components in order to create design systems. There's a lot of different companies that have decided that, hey, we're going to use web components because they can use them in React, they can use them in Vue, we could use them in the browser just in plain vanilla. So we actually just recently hired a designer to work on a component system at our company, and it seems to be working exceptionally well so far. I haven't seen any problems with it. However, I do kind of understand where a lot of designers are coming from, where you're kind of mixing the JavaScript, the CSS, and the HTML all in one piece, and that's one of the wonderful parts about the web components is you can just have these like very bare bone web components that represent my button, and you can still use the class attribute in order to style it up a lot nicer.
Thank you. Thanks for that, and thanks everybody for all the amazing questions. I think we're just about out of time. But Simon, thank you so much for sharing all of this. This was really, really fantastic. I say this to everybody, but it's true. I've learned so much from this talk. It's one of the things that I love about getting to be the host, is I get to focus on everybody's talk all day long, and just kind of try and pull those things together. So thank you again. I hope everything is going well in your neck of the woods, and that you have a great rest of your day.
Oh, thank you so much. And you too. And if anybody has any other questions, please just hit me up on Twitter. I'd be happy to continue the conversation there.